Yes.
What is design pattern? Why we go for the design pattern? So how many ways, types of design patterns we have?
Ma'am, singleton design pattern.
Mm.
Then uh,
Okay. We have three types of design patterns. One is creational, one is structural design pattern, and behavioral design patterns. So what is creational design pattern means at the time of creating an object or at the time of modeling like attributes or any object data members behaviors, in that way any changes we are going to do means those all coming under the creational design pattern. Okay. Structural design pattern means, for example, I need to separate the code to independently run my code. So we have to achieve the code to loosely coupling. There is no dependent between any two classes or any two interfaces or such a kind of things we are going to achieve under the structural design pattern. Okay. Behavior design pattern means already existing methods, already available methods, or behavior means some full of behavior of object. So in that object, how we are going to achieve the, I mean, very quickly to get the response instead of getting time delay and all. So making improve the performance of methods, behaviors of an object. These all are they are going to provide some solutions. Those are coming under the behavioral design patterns. Okay. So coming to creational design pattern, here we have a single turn design pattern. The name it is going to tell to us like single instance throughout our application. Single instance. We are going to create an object, a single object. That object we are going to utilize throughout our application. Whenever you want object means we don't want to create the object using the new operator. Simply we are going to use. Okay, I'm going to give the example for singleton. Okay, for example, I have a singleton object class. In that I'm going to create the object of this class. Okay, singleton design pattern. Okay, here I'm making my object as a static private. How we are going to achieve the design part a singleton design pattern means making my class object as a static private. Okay, and I use the static block to create an object of singleton. Here I just declared the singleton object. Here create an object, actual object. Here is the reference. Okay, and finally get object. Here only we are returning the object. How? See, this is the static methods. All are static block and the static methods, and the constructor of singleton should be a private. So you can't create the object like normal way. Just check here. We'll see the problem of this. Not problem. It's like the improvement of utilizing the method. You guys are getting, or is there any issue?
no, ma'am, no issues.
Okay. Okay. So I can able to create the object of singleton within this class, right? Singleton class object I am able to create in this class, right? Hello.
Yes, ma'am.
Yeah, here we are able to create the singleton object within this class. Okay,
Okay, ma'am.
now I want one more class. This is some main singleton singleton test. Okay, here I'm going to create the object for singleton. Is it possible or not? We will see. See what it is showing. Change the visibility of change the visibility of singleton to package. So here it is asking, this is the visibility. Okay, it is making as a private. The constructor of singleton design pattern, make it as a private. Okay, if you are make it as a constructor as private means within the class you can able to create the object. Okay, we are restricting the people to create the object of singleton outside of this class. This is what is happened here. Okay,
Okay.
at the same time I want to create the object, but I don't want to create every time. I want to utilize the same object throughout my application. Okay, for that I'm just using this way to utilize the same object wherever I want. See, I can able to call, right? I can able to create the object for a single turn, right? How we are creating means, see, what is the object of this one? This. So every time I'm going to utilize the same object throughout my application. This process we call it as a single turn design pattern. Okay, is there any doubt?
No, ma'am.
So how we are going to achieve the single turn design pattern? Anyone please? Hanshika, can you please? Hello, Hanshika. Hey.
Yeah, Nilamni.
Yeah, can you please let me know what is single turn?
In singleton, we
Sorry.
in singleton we create object for class only once, and we use for whole class.
Super. Why we go for the single turn, Anshika? What is the importance to create the single turn concept? Ariharan, can you please? You can.
To access in the global.
Not global and all. Here, the main intention of doing single turn means every time going to create the new object means our memory will go high. Utilization of memory is go high. So instead of that, if you use the same object means the same memory allocation only we are going to use. So due to this, we can effectively utilize the memory, and we are going to avoid the to create the new object to other people outside of the class. We can't able to create the object for single turn. See, because it is a private constructor, so we can't we can avoid the security. It will provide the encapsulation for our class. These are the benefits to use a single turn.
Okay.
Okay,
Okay.
okay, then we go for the one more um, I like design pattern. Okay, iterated design pattern. Okay, so here we know how the list and how we are going to iterate the data from the list, right? We have a iterate method. So from that, we are going to, for example, so I dot has next. So I dot next method. So from these only we are going to access the data, right? Okay. So from this, we are going to iterate the data, and we don't know the implementation details of iterator. Correct, right? Hello.
Yeah.
So in list interface, we have a iterator method declaration. In array list, we have a iterator method implementation. Okay. This is the list interface. We have a iterator definition declaration. Okay. And sorry, here. And here in array list, we have a list, iterator method implementation. One second. Yes, this is the one. So see, here we are creating a class and we are returning the object. So see here, what we are exactly doing. Has next means the size of the actual list. What is the iterator will do? Accessing the data. If for example in a list you have a 10 element means, if you want to know the first element, second element, third element, fifth, one by one we are going to access the data and we are going to print the data. That is what we done here, right? This is what we done here. This is iterator. Is there next element? Yes, is there mean it is going to inside and it is going to print the value using next method. And next it is going to the second, is there next value means it's going to the print the next value. If it is next value is available, it's going to the inside of the this while loop. This is the functionality of and having function of iterator. Okay. So,
Okay.
but here in array list, they are providing a default functionality for the next and has next, right? This is provided by the JVM, not by us. So if you want, make it to your own way means, we can do our own way means, uh, like how we are going to implement that facility, why we are going to override those methods means, okay, we have to make it, see, now I'm going to create one interface like iterator at the same, what is the available methods like has next and next. So we are going to return some method. This is the factory method. Okay. So factory design pattern we have, it's like a creational design pattern. So there is no here, what is happening? It's a tightly coupled. It's a merged with the list interface. So list array list method, inside of array list only we have this private class. So whenever we are going to create the array list, okay, whenever we are going to use the array list, in that list only we are going have a facility to write a access the data. But you are going to utilize, you are going to create your own iterator to implement this. Okay, see, this all my list, this all my iterator method in my own way. I'm going to iterate my method means this is the iterator interface. In this iterator interface, I'm overriding the has next method and next method. Okay, so due to this functionality and efficiently, I'm going to access my data. Okay, this is the way the behavioral design patterns will work out. Okay, it's already existing method is there, it's tightly coupled with a linked list. array list. This iterator method are available in a all array list, vector and linked list, everywhere is available. But this is the defaultly provided by the JVM, I mean Java persons. If you want alone your own implementation, means you have to go and you have to create a separate interfaces and try to create the one factory method. What is a factory method means? Okay, it's a simply just observe this class alone. Okay, I'm just creating the iterator. In that iterator interface, I have a declarations of has next and next abstract methods. Only declaration is available. Next interface is a sector. I mean, here I'm just creating the iterator one declaration of method of iterator. Okay, before we have a iterator method, here I'm making as a get iterator. This is not in this way we have to follow and all, it's not required. In your own way you can able to iterate, you can override in your own way to achieve the best performance. Okay, your guys are getting me, or is there any confusion statements? Let me know please.
Okay, no confusion at all.
Sorry.
No confusion.
Yes. Okay. Here, and I created next iterator. Here, I just declared a method get iterator. Okay. I'm creating one class. It's my repository, I mean data class. So in this data class, I'm trying to implement the sector. Implements means we are going to override the get iterator. The main intention of get iterator, I want to iterate the employees of data. Okay, for my employees data, for my own class, I want to iterate the data with my own way. Now, I don't want to depend on my list provided. What is the list interface provided to me iterator? I don't want to use that. My own way I want to iterate. That is the solution they gave. One way is, this is the way to give the solution to best way to perform our iteration. This is the one. Okay, here I just override the method of iterator of sector. I mean method of get iterator, method of sector. Simply here I'm trying to give the new object of this. Again, I'm going to create the new employee of iterator. Here I'm going to I implements the actual methods of has next and the next. Okay, here index is, for example, to reach the less than employees means uh, how we did in class. See here, we are checking, right? If the next element is there means we go inside, it is a true or false. This is the actual condition, right? That is what we are doing here. Okay, if the employee length is less than means it's always getting to true. So we'll go and we'll print the values of list what and all we have. And otherwise it is going to false means will come out of from this while loop. Okay, and next method is the value to print the value of employees. All employees data I want to print. So this is the mean means employee of 0, employee of 1, employee of 2, what and all have the data. That index we are going to pass and we are going to print. Here we are passing the data, right? So has next and everything. So this is the way we are going to return the iterator and behavioral design patterns. Okay, this is the way to we are overriding the methods and we are going to achieve the best performance. Okay, they provide some solutions with a different ways. If you have to change any design behavioral design way means, I mean between objects, you have to go any one of these solutions and utilize that to achieve the best performance. And coming to structural, I'm going to give the example for adapter and the same time bridge. Coming to here, so so okay, adapter pattern. So what is the mean of adapter? The name it is telling, we have a different uh, classes or different interfaces but I want to get the two different interfaces and two different classes behaviors into a single class. Okay, so we'll see what is the different interfaces. For example, I have one different interface, one interface like a bird. We have a two abstract methods like a fly and make a sound, and one more interface I have, that is a toy duck. Okay, here what is the intention of this adopter means, you have a actual birds and you have a toy dog, toy sorry birds. Okay, you have a actual birds and you have a toy birds, but both have a different behaviors, but I want to create an adapter to make it work for actual birds and make it work for toy birds. Okay, that adapter how we are going to achieve using the classes, that is we are going to see in here. These kind of way and these kind of design patterns is nothing but structural design patterns. Is there any confusion on this example, explanation or something else? What is a structural adapter design pattern?
Nilamni, could you please repeat?
Can you please let me know what you understand about the structural adapter design pattern?
What?
Structural adapter design pattern. Now I explained, right? What
Yeah.
is a adapter means? What is the importance of adapter? Okay. So here adapter means if you have a two different interfaces or different behaviors in a different classes means I want to make it into a single class and a single behavior to work for one interface and work for another behavior. I mean two different behavior also. Here, for example, I gave actual birds are there and the toy birds are there, but I need one class. I need to work out for the actual birds also need to work and the toy birds also need to work. That kind of functionality we are going to achieve using the adapter structural design pattern. Okay, we'll see the example. One is bird interface. We have a two methods, abstract methods. It's a fly, make a sound. Okay, adopt sparrow. For example, actual bird is a sparrow. Here I'm implemented that bird interface. Here I simply printing something like a system flying or something implementation I did in a sparrow actual bird, and I'm creating one more interface like a toy desk. It's a how the speak will work, that I simply declared one method. So this is the plastic toy desk. I implemented that one in a plastic toy desk. So here we have now two different interfaces. One is bird, actual birds, and one more is a toy desk. But I need a adapter between these two different interfaces. Adapter I'm going to create now. It's like a bird adapter. Now I implementing the toy duck. Okay. In that toy duck, okay, we have one method that implemented in the bird adapter. Now this is the constructor to make it a bird. I mean, what is the bird? This bird is actual bird, right? I'm
Yeah.
implementing the toy duck and I'm creating the, okay, I'm creating the bird object. This is the actual bird. In that object I'm giving to here, because this adapter is going to act as the work for actual birds and the same as the toy birds. In that way we are creating a class. This is the way to make it as a adapter between the two different interfaces. So here what is the main thing means, here we are creating the interface of a bird. Bird is interface, right? that interface reference we created here and we are assigning to here, how the actually we are utilizing to access and achieve our actual function. Like my adapter is going to give now actual bird implementation details and the same time toy implementation details. If you go to the main and see, I'm creating a sparrow object. So in sparrow object, what and all is there functionalities? In sparrow class, what and all methods are available? Implementation details.
Fly and make sound.
Yes. Okay, in main method, we have a two methods in a sparrow object. We can able to call fly method, make a sound. This is the sparrow actual bird functionalities. But my intention is with the toy duck, I need to get the actual bird implementation also. Okay, this is the toy interface reference I'm creating and creating the class object of plastic toy desk. Now I can able to call Spark and the same time one more thing I want to give the object of this sparrow. See, you seen right in bird adapter. This is the plastic toy because it is giving the individual functionalities. Like this object is going to give the only toys, but this object is going to give the only actual birds functionalities. My intention is I want to make a adapter to return the two functionalities, right?
Yeah.
So that is the what here I'm passing the object of sparrow, that is I'm giving to here. In adapter, I created one constructor to pass that bird. That bird, this bird only making the sound. So in this make sound where it is bird. So finally, what is happening? In a toy duck, how we are going to make a sound also? We are overriding and we are utilizing this toy duck. Now it is working as a, you got what I'm trying to tell, right?
Yeah.
So, okay. So this object I'm giving to here, now this adapter, this bird adapter can able to, this is the actual bird. This is the toy bird. And this is the adapter. Toy duck behaving like a bird. See? Okay. This is the small simple example how we implemented and all check properly. Okay.
Okay.
This is not only like we have to follow this way alone, not like that. You can give, you can utilize this constructor in your own way and you can do whatever you want. Instead of bird make sound, you can do some fly also. Okay, there is no mistakes and you can do more. Instead of that, you can call one more something like a toy duck. We have this, right? So I'm going to create the object here, p equal to, it's like our own way to call our functionalities. Okay, spark. So if I'm going to run this method means, so if you spark means what is going to give my output? What is the output of this? I changed this adapter method, right? So in fly means what is the output? Flying. Okay. And what is the spark? I'll simply going to return the spark. So if I'm going to run this method means I just want to make it to this one is okay comment. Then we'll how the type the bird adapter is how it is going to work. See, bird adapter. First it is flying and the same spark. So why it is acting like that means I implemented in my own way. I want to do the bird as a flying, and the same time, plastic toy need to call like a spark, speak. Okay.
Okay.
Okay, this is the way we have some design patterns and solutions to write a. I mean, it's like a this fall. If you follow this way, means our code will be a utilized to everywhere. There is no depend on each other. Okay, here we have a two different interfaces, right? If some another peoples will come and can implement it their own way, this speak or something like, and board and fly making sound, these methods, some birds now instead of sparrow, some another bird is coming, means in based on bird they are going to override this fly and make a sound methods. Like this, it's going to be an adopter. This is the flow, like structural design patterns. Here we are separating the two interfaces and abstractions. Implementation details and declaration is separated. You guys observe that? See, see, if I'm going to coming from here, means it's going for declaration. It's not from sparrow implementation detail. This is not calling, but internally it is going to call this one and it is going to print. Okay, so you seen the actual importance of using the adopter and this kind of design patterns, right? We are separating the implementation details and declaration. Okay, any doubt till now?
No, no.
No, no, ma'am.
Okay. So one more design pattern I want to tell you. That is one more example for structural design pattern. Okay. These all are like some small examples. Like here we are going to achieve the abstraction. I said, right, only declarations is a questions. Have some declaration, next question, previous question, new question, something like that. And if I go for the implementation, means Java question, I'm implementing the question bank. Okay, question. So here actual functionality I'm doing in a Java questions. But if you come to the actual test bridge pattern demo, okay, here coming to see this question format also, here just simply showing the display of all the questions and answers, how we are separating the things, how we are going to display the all the things. Okay, display the all the values, all questions, all answers, like that I'm displaying all the questions. If you coming to the manager, see, this is the we are separating. If you going to call the next method, inside of next method we are calling the next question, but it is coming to the interfaces method. You are not going for the implementation details, but inside we are going to call the next question. This is the actual function it is going to run. Okay, we separated, right? This is the declaration, this is the implementation, this is the way of calling that questions. Okay, this flow and separating of abstraction or implementation details is nothing but a structural design pattern. Okay,
Okay.
so finally bridge pattern, how we are going to run. So I want to add, or I want to add, delete, I want to display. See, if I'm going to display, means where it is going, here. Actual question, display question is what, here it is going. But thing is, I'm implementing what I actual implementation of display question dot get current. Whatever the thing is there, that current question need to print. This is what we implemented in this display question. Maybe you can do whatever you want in this, maybe system simply hello, like that, whatever you want. Okay, but think, see, you separated the functionalities, how you have to see new one. This is the method we are calling question manager, but inside of the question we are calling this actual implementation available in a Java question dot class. New question. Here manager only we are calling new one. This new one only we are calling here. How we achieved this? We are creating the object of question. We are creating the object of question in a question manager. Okay. In that question have a methods like a question is interface, right? In question object, how we are creating a new object, that declaration and all we did. Okay, new question. That actual implementation is happened in here. List of class, list of array list we took, all questions and all we added. Okay, and how we are next question means we are doing, how we are doing. See the question manager carefully. What is happening? We separated all abstraction and interfaces data, right? Any
Yes.
doubt here? To call these methods, or see here we create the object of new Java class application. What is a question.q means? It's a q is the question format. We have a question object. Okay, that is the interface object. That interface object I'm creating the actual question object. Okay, in that question object only we are doing this all functionalities. But actual question manager, this is the object of question manager. In that question manager we are calling this delete method and display methods, display all method. Inside of that we are again calling one more method. Actual functionality is happening like this. This all functionality we achieve using the new object of that Java question. Any doubt?
No, no, no.
Okay, what is a bridge? Why we are calling a bridge means this question manager is a bridge between the question actual interface and the implementation class. Correct, right?
Yeah.
So this question manager is a bridge between these two question and Java question Java dot class. Okay, these two we are making as a one class and implemented method. Here we are calling, so it's a question manager acting as a bridge. So how we are going to create the bridge means the interface we are creating and the actual object creation of Java object we are creating in a our main method. So through that I'm going to achieve my functionalities, calling functionalities. So here question manager acting as a bridge. This is one way of structural design pattern. So here the main structural means it's going to happen between the classes, interfaces, like that. The structure of class, structure of interfaces, we are going to do some solutions they are providing to us. Okay. So this is about simply about types of design patterns. Okay. Then can you please till now let me know what you guys are understanding the design patterns? Why we need a design patterns? What is a creational design pattern? What is a structural design pattern? What is a behavioral design pattern? Anyone please give me some small explanation.
We use design pattern for reusability,
Yes.
and these patterns show the relationship between the classes and interaction between the object. Sorry.
Correct. Means effectively if you want to utilize the memory means maybe the importance of singleton, you can use that concept. Okay, if you want any iterator performance wise, you have to improve means you can use the design pattern, iterator design pattern. If you want like a bridge pattern, like you want to create like a bridge kind of things to different interface and a class, and you are going to hide the implementation, and you are going to achieve the encapsulation using the bridge design pattern. And one more thing, adapter. Here we have to achieve the two different behaviors into a single behavior, I mean in a single class. So we are going to create the adapter for accessing the functionality of two different different peoples, or two different birds, or two different any behaviors. Okay, so we can go we have a solution like uh, adopted design pattern. Okay, this is the data pattern is we can use, and we can go for that, and we can based on that we can create our own design, adopted design pattern. Like that you guys need to think. Okay,
Okay, now.
yeah, this is about a design patterns till now what we are discussed. Okay, reminding and all, just go once, everything is a single things, some small explanations. Like a decorator, the name it is telling like decorator, for example. And I'll give you some small example why this decorator will come. If you go to the Pizza Hut, or going to any McDonald or something else means, everyone have their own taste. For example, Anishka is liking pizza like paneer, but paneer pizza means maybe I'm going to like a chicken. Okay, and decorators means I want spicy, but Anishka don't want spicy. Just imagine, okay, this is the functionality. What kind of decorators? The name it is telling decorator, but one more thing, I like some fruit kind of flavor in my pizza, maybe pineapple or some another, some different flavors I need. So based on specific things, we are going to give some solution. That solution is given by decorator. Okay,
Okay.
if you go to that decorator example once means you get to know the, okay, I how I'm going to achieve a no one together, we don't have a same taste, right? Everyone have their own taste, and everyone have their own implementation things. The default the default solution they provided to us. If you have any doubt or any way, you just go and check that decorator. At the same way, we have so many composite, proxy, flyweight, like that. Just go and check it once. First, for interview or something means we need to know the what is exactly, what is a creational, what is a structural, what is a behavioral, and give some small example clearly about them. Okay, it will enough for us. Okay, no one will ask the everything. Okay,
Okay.
okay, that's what about a creational sorry, design patterns. Is there any doubt means let me know till now, and then we'll wind up this session. Ariharan, have any doubt?
No, ma'am, no doubt from my end.
Okay,
I'm okay.
yesterday today everything is clear, right?
Yes,
Yeah, thank you Ariharan, and thank you Anshika.
thank you, ma'am.
Thank you so
Yeah,
much, everyone.
yeah.